So for my project, I wanted to do a kinematics question. So I'm going to read the question out first, and then we'll get started with part 1. So for part 1, the question is, a family from Massachusetts is on their way home from a July 4th Cape Cod trip. After over an hour of bumper-to-bumper traffic on the Sagamore Bridge, they finally get to continue their journey home. The angry father accelerates his minivan uniformly from rest. It accelerates at a rate of 3 meters per second squared for 8 seconds. So first what we want to do is we want to write down our knowns. So our acceleration, we have that, so that is 3 meters per second squared. And then we also have our time, which is 8 seconds. That'll be t equals 8.0 seconds. And then it says in the question that the father accelerates from rest. So we would know that v naught equals 0 meters per second. And then our initial value for x would be 0. So for A, the question asks, what is the car's final velocity? So for this question, what we want to do is we want to use the equation that is v equals v naught plus at. So we'll write that down. Equals v naught plus at. And like I said, for all of our knowns, v naught equals 0, so we can cross that out. So it'll look just like this. And then moving forward, what we can do is we can say v equals at, and that also has our final velocity right here, and it's already by itself, so we can go ahead and plug the numbers in. So we will have v equals 3 meters per second squared, and then we will have our time, which is 8 seconds. So all we have to do for this one is we have to just multiply 3 times 8, which will be 24 meters per second for our final velocity. And that is part A right there. So then we can move on to part B. And part B asks, how far does the car travel in this 8-second interval? So for this one, we want to use the equation that is x equals x naught plus v naught t plus 1/2 at. So I can write that down. T plus 1/2 at squared. So it'll look just like this. And like we said, for the same for part A, v naught equals 0, so we can cross that out. And then x naught also equals 0, so we can also cross those out. So then we can rewrite our equation into x equals 1/2 at squared, just like that. So then we can go ahead and we can plug the numbers in now. So we're trying to find x, and it's already isolated by itself. So then we can go ahead and we can do 1/2 times a, which would be 3 meters per second squared. And then our time, which is 8 seconds, and that can be squared, just like that. And then we can go ahead and do x equals 3 over 2. This can be simplified from the 1/2 times 3, and then times 64, which is our 8 squared. Just like that. And then from there, we can multiply those together, and that will give us 96.0 meters for our total distance traveled in those 8 seconds. So now that's the end of part A, and then we can go on to part B. Okay, so now moving on to part 2 of my question. The question states, immediately after reaching this speed, the car continues at a constant velocity for another 12 seconds, where they unfortunately meet even more traffic in Plymouth. So for this, we want to write down our knowns again. So it says for another 12 seconds, so our t equals 12 seconds, and then our velocity, we will use that velocity, the initial velocity that we got, which will be 24 meters per second. And then our acceleration, it says that it's moving at a constant speed, so that's how you know that our acceleration equals 0 meters per second squared. So those are the knowns that we can write right there. And then, so for part A of part 2, it says, how far does the car travel during this time? So for this one, you want to be able to get x. So we're going to use the same equation that we just used in part B of part 1, and we'll use x equals x naught plus VOT plus 1/2 AT squared. So that's the equation, have that right there. And then, so what we want to do is our initial x, we can cross that out because it equals 0. And then we can also cross out the 1/2 AT squared because we already said that our acceleration equals 0. So then we can rewrite our equation to x equals v naught t. It'll look just like that. So then from there, our x is already isolated by itself, so we can just go ahead and plug in the numbers. So x equals 24 meters per second, and then we can multiply that by the 12 seconds that the car is moving constant, and our x will equal 288 meters. Box that. So just like this. And then we can move on to part B. And part B says, what is the total distance traveled by the car over the entire motion? So for this, all we have to do is we have to take the x that we got from part A, which was 96, and then the x that we got from part B, which was 288, and all we have to do is add those together. So our x total equals our x1 plus x2, just like that. And so then we can say x total equals 96 plus 288, just like that. And for our total distance traveled over this whole time period was 384 meters. Just like that. And that was the rest of my question.